Today we'll be working on solving compound inequalities. Compound inequality is basically two or more inequalities that are connected by and or. Or normally what's going to happen is when you graph the inequality, arrows are going to go different direction, and when you combine it, it's going to show a range. So if we look at this here, we're dealing with or. Both inequalities are solved for. When it's solved for, basically what you need to go ahead and do is graph the solution set on that number line. So I look at my two solutions there, and I see I have 4 and 2, so I need to make sure that my number line can hit 4 and 2. So I'm going to go ahead and start 1 here, 2, 3, 4, and 5. Now, when you do this, it's easiest to go ahead and read from your variable. So here's my variable, p. Well, notice p is going to be greater than, because the alligator mouth eats the bigger number. So p is greater than or equal to 4. Greater than or equal to has a closed circle. And if you read from your variable, it tells you what direction you need to go. It says p is greater than or equal to. If it's greater than or equal to, greater than values are to the right. Next one, p is less than or equal to 2. Again, the alligator mouth here is eating the bigger number. P is not bigger, so you would have a closed circle on 2, and p is less than, so the arrow is going to go to the left. And there would be example 1 graphed. Example 2 is going to be pretty similar. The only thing that is different about it is basically when you look at it, it is not solved. So we need to go ahead and get r by itself. So we'll break these two inequalities down. Again, we have or. You need to get r alone. In order to do that, I'm going to go ahead and subtract 6 from both sides. And I'd have r is less than negative 8 minus 6 is negative 14. Here I'm going to add 3 to both sides. And I have r is greater than negative 7. So again, my graph here has to hit negative 14 and negative 7. Again, taking these two number lines, or two inequalities here, or those values are going to be going out. We look at this, read from your variable. R is less than negative 14. So it is an open circle on 14, and it says r is less than. Those less than values are to the left. Again, read from the variable. R is going to be greater than negative 7. So we find negative 7 on the number line. The values that are greater than negative 7 are to the right. Here's what the graphs are going to look like when we run into a problem with and. So we're going to go ahead and solve for m here in both of these problems. I'm going to go ahead and subtract by 7 to this problem. We have 2m is greater than or equal to 13 take away 7 is 6. Solve for m. Divide both sides by 2, and we have m is greater than or equal to 3. Again, I'll solve the other problem. I'm going to go ahead and subtract 12 from both sides, and I have 5m is less than 25. Get m alone. Divide both sides by 5, and we have m is less than 5. Now I have my two inequalities here. I can go ahead and make that compound graph. I have 3 and 5 my graph needs to hit. Looking at that first inequality here, read from your variable. It says m is going to be greater than or equal to 3. So on 3, that is going to be a closed circle. And you just said that m is greater than 3. If it's greater than 3, the arrow is going to be going to the right. Now, one thing to notice about and is this is what's going to happen. Notice I didn't put an arrow on this yet. Read from your variable, and that second inequality we have m is less than 5. That is going to be an open circle on 5, and it says m is less than. So that arrow is going to go to the left. Now what this is doing is basically showing a range of values. Note the difference between the graphs between and or and. Example 5, notice that the inequalities aren't really split up for you. It's that compound inequality look to it. Basically, when you're dealing with a compound inequality, it has 3 sides. There's a couple ways you can solve this. I'm going to show you the longer method here in example 4, and then we'll shorten it up in example 5 and 6. So the first thing that we're going to do is we're going to break this down into two inequalities. So I'm going to box in the first inequality. That first inequality is -2 is less than or equal to x minus 3. Now you're going to go ahead and take the other inequality out of this, and I'll go ahead and circle it. So we have this part right here. We have x minus 3 is less than 4. So in both these inequalities, you're going to go ahead and solve them both. Get x alone. So I'd add 3 to both sides. I have 1 is less than or equal to x. Over here I'm going to add 3 again to both sides, and you have x is less than 7. Now we can go ahead and graph these two. And again, my graph needs to hit 1 and go out to 7. So we'll go ahead and start it with 1. Now looking at my two inequalities here, when I break them down here, I have read from your variable. It says x is going to be greater than, because the alligator mouth eats the bigger number, x is greater than 1, greater than or equal to 1. So we have a closed circle on 1, and x is greater than, that would be going to the right. We have x is going to be less than 7, so it will be an open circle on 7, and that arrow would go to the left. So again, showing the range, that compound inequality, that and value. When you write this, basically what happens here is these x values come together. So x would be in the middle. You're just going to drop down your inequality sign, drop down this inequality sign. So here's was basically what it would look like if you were to rewrite that compound inequality and then the graph below. Now here's another way you can go ahead and solve this. If you look at example 5, instead of breaking them down into two inequalities such as this one and that one, there's another way you can go ahead and solve this, and you can attack it like a three-headed monster here, because there's basically three sides. Those sides are split up by your inequality signs. So I'm going to go ahead and drop those inequalities down. What you have to do is get x by itself. X is in the middle. You have 5x plus 7. So we need to get rid of 7. Subtract 7. You're going to do that to all sides. 20 take away 7 is going to give you 13. Drop the inequality sign down. 5x is going to drop down. 7s would cancel out. Inequality sign drops down. 80 take away 7 is going to be 73. Get x alone. In order to get x alone, you're going to divide it by 5. Drop my inequality signs down. Everything is being divided by 5 here. Now when I divide, basically what you wind up with is 13/5 is less than x. This would be equal to, less than or equal to. And we have 73/5. Now when you graph it, it's not so pretty here looking at those improper fractions. So maybe convert it to a decimal would make that a little bit easier. We would get 2.6 here, and this would be 14.6 here when you actually divide it. So that's what I need to hit on my graph, and I'll just make a generic graph. So maybe in my graph I'm going to go ahead and start with 2.6 because I need to make sure I get to 2.6, and I'll go up to 14.6. There's my generic graph. It's just going up by 1, basically starting from 2.6 to 3.6, 4.6, 5.6, all the way up to 14.6. Looking at my inequality, now when you attack it the way like a three-headed monster, so basically what you're going to do is you're going to go ahead and deal with this part of the inequality here first. So you have, really is what this is saying is reading from your variable that x is going to be greater than or equal to that 2.6. So you would have a closed circle on 2.6 because it is greater than or equal to. Now if it's greater than or equal to 2.6, that arrow is going to go to the right because those are the values that are greater than 2.6. Now the next thing that you would do is take this part of your inequality. So you break it down this way for the graph, and it says, again, reading from your variable, that x is going to be less than, well, we know that is really 14.6, and that is an open circle on 14.6. Since x is less than, that arrow is going to go to the left. So basically what's going to come together here is, again, it's showing that range of values between the two compound inequalities there. On to the last one, example 6. I want you to go ahead and give this one a shot. Again, tack it like we did in number 5, that three-headed monster there, so make sure that it has like 3 distinct sides of the compound inequality, and then we'll check back in. So go ahead, pause the video, and try to work example 6 out. Step 1, subtract 6 from all sides, and then we have that new inequality there, negative 2 is less than or equal to negative 2x, which is less than 14. Need to get x alone. So we divide it by negative 2. Now when you divide by a negative number, reminder, when you multiply or divide by a negative, the inequality signs flip. So we have to flip those signs. And then we can go ahead and do our computation here, which is 1 is greater than or equal to x, which is greater than 14 divided by negative 2 is negative 7. So again, when I graph this here, I need to get from 1 all the way to negative 7 here. So I'm going to go ahead and sketch out my number line. There's my number line. Take care of one part of it here first here, this inequality, and read from your variable. X is going to be less than or equal to 1. So it is a closed circle on 1. We said x is less than or equal to. That arrow is going to the left. Now we'll take the second part of the inequality, read from your variable. X is greater than negative 7. So if it is greater than negative 7, it would be an open circle on negative 7, and greater than would be to the right. And again, here's that compound inequality showing the range of values there. This will conclude compound inequalities.